the second session today that we have. And this session will be a session from Pieter Vanhove. He's one of our core members of dataMinds as well, and we're really glad to have him present on such a fantastic topic. Because we're seeing a lot of people are saying that DBAs are being irrelevant and they're called dinosaurs and whatever not. But Pieter is a firm believer that that is absolutely not true. I will leave the introduction of himself further up until him, and then he'll go straight into presenting the session. So go ahead, Pieter. Thanks.
Yes. Hi. Good evening, dataMinders. Thanks for joining my session. I'm also inside, so it's too bad it's good weather outside, but I'm glad that you joined my talk. So I will try to not go over my 90 minutes, but probably it will be less, but we'll see how many questions we'll have. All right, let me share my desktop first. Okay, so now you should actually see my presentation.
Yep, it's coming through.
Okay, perfect. Okay. My name is Pieter Vanhove. I'm a solution architect at Microsoft, and I work in the data migration jumpstart team. It's a team, and we're actually helping customers migrating from on-premise SQL Server to an Azure data flavor. That could be Azure SQL Database, could be managed instance, or even SQL Server running in a virtual machine. Not only do we help migrating from SQL to SQL, but also other data platforms like Oracle, PostgreSQL, and so on. We help those customers moving into the Azure platform. Okay, enough about me. Today, I want to explain 10 DBA tasks for Azure SQL Database. I was a DBA for many years myself, and I want to compare what you usually do on a, let's call it a traditional SQL server, and how we actually doing it right now in Azure SQL Database or managed instance. So I'm always going to compare the DBA task itself. All right, before I kick off, perhaps if you can use the chat windows. What is, according to you, a task for the DBA? I don't see anything coming in yet. Buddy?
Yeah, there's a delay, so
okay.
That's okay.
Okay, just saying no. Yes, that's the default answer. That's right. Yeah. Anything else that pops into your mind? No?
Tough crowd.
Yeah. Hello. Okay, anyway, if you don't want or if you cannot respond, not a problem. What I have done is I have actually listed up the DBA tasks that I think of that, okay, these are actually, okay, we have an answer. Backups, okay, yes, indeed. Database maintenance, correct. These are all database tasks. Backups, yes. Database performance and being a wizard. A wizard, wow. I'm not a wizard, no. Restricting access, yes, especially for Benny. That's right. Yeah, so these are the tasks that I listed and that I came up like, okay, these are relevant DBA tasks. Let me go over them quickly. So first of all, we have, let me use my laser pointer here as well. So first, mainly what DBAs have to do is they need to install SQL Server. So I'm going to compare how can you install an Azure SQL Database or a managed instance and compare that to a traditional SQL Server. After that, you usually have to configure the databases on the servers. What are the different database settings that you can use? Next is indeed, as somebody mentioned in the chat as well, backup and recovery. You are responsible, and according to me, that's the most important task of a DBA, is to be able to recover your database at any point in time. So make sure that your backups and also that your recovery is working. So big task here for the DBA. Patching. You need to make sure that your SQL Server instances are up to date with the latest service specs or CUs. Somebody else in the chat mentioned indeed database maintenance. Yes, so we need to do index maintenance. We need to do update statistics, database integrity checks, stuff like that. Correct? HADR setup. Usually it depends on the application, but you could set up always on availability groups, for example, or you could use failover clustering. So I'm going to compare here as well. What are your HA and DR options that you can configure in Azure SQL Database and managed instance? Security. Indeed, somebody else in the chat mentioned restrict access. Correct. So you are also responsible for permissions and authorization and authentication against your SQL Server. So we're going to shortly have a discussion on that as well. Job scheduling. Sometimes applications, they need to have jobs running in the background or during the night to do a load, for example, of tables or to modify something inside the database. How can you schedule a job in Azure SQL Database? Data migration, of course. Sometimes you need to migrate from one SQL Server to another. How can you do that in Azure SQL DB? And last, somebody also mentioned in the chat, review performance metrics, or how performant is your database or how performant is your SQL Server. Right, lots of stuff we need to cover. I won't go much into detail on each topic, otherwise, I would need to have some time until tomorrow morning, I guess. But I will briefly, explain every topic. Feel free to drop questions in the chat. Benny will handle those. All right, let's start with the first one. Install SQL Server. So usually in an on-premise world or in an IaaS world in Azure, you need to configure your virtual machine. Then you need to configure the disks. You need to configure the network on your server. You need to install your operating system, and then on top of that, you need to install SQL Server. So until you get to the point of installing SQL Server, there might be already some time that go over that as well. Now, in Azure SQL Database, we have 3 different flavors that you can install as a servers between brackets. So we have a single, we have elastic database pools, and we have a managed instance. Now, a single database or standalone is assigned only for one specific certain load that you need to have on your database. So it's just one single database that you're going to use. Elastic database pools or elastic database pools is when you're actually using a shared model. Typically what we see is, for example, each customer has his own database, but your application is using all these databases in one time. So that's elastic database pools. And then we have managed instance, which was already introduced a few years ago, which is you get a full-blown SQL Server instance like you used to have, but you get the advantage of the PaaS solution as well. So you don't have to worry about disks, you don't have to worry about operating system or about patching. That is all done by Microsoft, but you get a full-blown SQL Server instance, right? So once you decide that you want to start with SQL Server on Azure or even a PaaS solution, you have to pick one of those. It could be single database, it could be an elastic database pool, or it could be a managed instance. Now, if you go for a single database, what are the things that you need to configure? First step is you need to configure in the Azure portal or with PowerShell or with another or REST APIs, it doesn't really matter, but you first need to create what we call a logical server or logical endpoint. And the only things you have to configure there is just the name of your server, a server admin login, which is basically, it's not 100% a system administrator user, but you can compare it like that. So it's the server admin. You need to specify a password, and you also need to specify the location. Where do I want to create that logical SQL server? And that's it. And then you have your SQL Server. So you just hit OK, and then it will, or we will spin up a logical server for you in just a few minutes. If you compare that to installing a traditional SQL Server, it could take a few more minutes more until you have your instance available. Now, if you compare that to managed instance, we have different settings there, even more. So here also we need to configure the instance name, also the admin login and the password, and again the region. Where do I want to create my managed instance? Now, managed instance itself, then afterwards you need to configure the size. Do you want to have it general purpose or business critical? I'm going back to these two flavors or in a few slides. And you also need to specify the size of the storage resources. So how much storage do you need on your managed instance? And once you've configured that, you need to configure a virtual network, the connection type, and whether you want to use a public endpoint, which means that your database will be available in and that your managed instance will be available over the public network, yes or no. So these are all the settings for managed instance. Just hit OK, and then we are going to deploy a full-blown instance for you again. Oh, yeah. In a managed instance, you also can configure the collation, something different compared to Azure SQL DB, where you cannot configure the collation. The time zone, you can also configure that, and you can also specify whether you already want to use geo-replication, yes or no. But I come back to that again later on when I'm going to talk about HADR options that you have. All right. Good. That's basically it. Just fill in some settings, hit OK, and we are going to deploy that server or that managed instance for you. Does that make sense? Are there any questions on this?
Yeah, there is one question actually from Eep or Abe. Sorry, I'm screwing up the name. He wants to know about Azure SQL Database. If the database gets corrupted, is it fixed by Microsoft, or should the client themselves run DBCC CheckDB?
That's a very good question. And I'm going to talk about that when we're talking about database maintenance, because I have a few slides that where I'm going to talk about DBCC CheckDB.
Yep,
yes.
Perfect.
So,
no other questions so far.
All right, so hold on. You'll get the answer in a few, let's say half an hour. All right, good. Now, once you have your logical server or your managed instance, then you need to start configuring your databases. Again, if we look at the deployment, the different deployment models, so we have single elastic database pools and managed instance. In the single deployment model, we have an option, what is called serverless. I'm going to explain that immediately more into detail. But what are the other server tiers that are available for all the different deployment options? These are general purpose, business critical, and hyperscale. Now, so you need to pick one of these three server tiers for every database, or in the case of a managed instance, you need to specify that at the time of creation of the managed instance. Yeah. Now, what's the difference between general purpose, business critical, and hyperscale? If we look here, general purpose is mainly suitable for a day-to-day application that doesn't need much performance at all. Well, it doesn't need much performance. It's for, let's say, the regular budget-oriented workloads. Yeah. Business critical, so you have to choose that option if you really have business critical applications that need high throughput and that also have high I/O requirements. Yeah. Now, there are some limitations on business critical, for example, the size of the database. So you can go up to a maximum of 8 terabyte in a managed instance. Yeah. Now, the thing is, sometimes we have customers and they have, but my database is larger than 4 terabytes or 8 terabytes. I cannot use any business critical. That's correct, because then we can provide you with another which is what we call hyperscale. And this is mainly designed for very large OLTP databases that needs to scale a lot in storage and read scale requirements. So this is really for the huge databases. So you can go up to 100 terabyte of storage, and that's just a soft limit. In reality, we can actually go above that. So yeah, these are the different flavors that we have. So you need to specify that on the database level or on a managed instance level. If we look at the single databases, you can actually go for a computing. So we have two different flavors. We have a Gen 4 and Gen 5. Gen 4, you can select up to 24 vCores for just one single database. Or if you select the Gen 5, you can even go to 80 vCores. Same for managed instance. And here on business critical, we have also the same. So 24, 80 vCores, and so on. Storage maximum size is 8 terabytes. And here, here we're using premium remote storage, which basically means we're using Azure storage under the hood. If you go for general purpose, if you select business critical, we're actually using local SSD disks. So the IOPS, the read IO, is much, much faster, as you can see. So in general purpose, we have 2 milliseconds for all database access. In business critical, we have less than 1 millisecond for all database access. So it's really for critical workloads that you need to specify business critical. For availability, under the hood, we provide 3 copies of your database. So we have 2 read replicas that are available. In business critical, we have 3 replicas, and one of them is read scale. So if you are familiar with always on availability groups, in business critical, we also have the functionality to have 1 read replica. So you can upload your readable queries to one of the other nodes that we are having under the hood there. And we also provide zone redundancy. So every Azure region is split up in different zones, and the databases can be replicated over the different zones. That gives you an extra option for high availability. All right, so these are the 3 different flavors that we have: general purpose, business critical, and hyperscale. So as a DBA, you need to define, what do I need? Do I need a general purpose? Do I need business criticals, or do I really need to go for hyperscale here? And that's something you need to discuss with the application owner, with the business. Of course, it's worth mentioning, the more vCores you pick and the different options that you choose, the higher the cost can be, of course. Yeah. All right. Now, one thing I didn't mention was the serverless option. Yeah. Now, if you look at this graph here, so we have the compute vCores. So I have selected, for example, a database in general purpose, and I say, okay, I want to use 4 vCores for this database. Fine, but you will be charged for 4 vCores, of course. Now, if you look at this timeline and the number of vCores that are used, so let's assume this is 24 hours. So people here, they start working, so they come into the office or they log in remotely nowadays. They start working, so we're actually using 4 vCores. Then, okay, the usage goes down a little bit, goes up again, and then people go home or they stop working. And then all of a sudden, nobody is actually using that database anymore until the next morning. So basically, it means if we look at these blue area, this is unused compute resources, but you still have to pay for it because you configured 4 vCores, right? To address this problem for our customers, we introduced serverless. And serverless basically means that you need to configure on your database a maximum number of vCores, in the same example here, 4 vCores, and also a minimum number of vCores, here in this case, just 1, right? Now, so from the moment you go above that 1, okay, you will be charged the number of vCores that you're actually using over time. Right? So here in this case, the blue area, again, you will be charged. Again, after what is it? Let's say 6 o'clock in the evening, people are stop using the database. And actually what will happen is you can define an auto pause delay, which means if there is an inactivity during a certain period of time, could be 1 hour, could be 1 minute, then we can actually say, okay, this means this database is not used anymore, and we're going to pause the database, which means you're not going to be charged anymore for the vCores. You're only going to be charged for the storage that you're using. So in that way, you're using your database more optimal, and also the costs for your database will be actually reduced in this case. Is this suitable for every type of workload? I wouldn't say no, but for example, in a development environment where you know that the application is not used in the evening and the night, that could be a very good candidate. Same for applications that are only used during office hours, for example. You could go and look into the serverless option. Yeah. All right. What other considerations do we have related to database configurations or server configurations? Attaching a database is not supported, so you cannot do that in Azure SQL Database or managed instance. That is not possible. Only Active Directory is supported. So Windows authentication is not supported, and that's usually a problem when you want to migrate your database from an old version of SQL Server running on premises, and you want to move that to, for example, a managed instance. Azure Active Directory is not supported, and typically that old application cannot support Azure Active Directory, right? So yeah, the only option that you have there is go for SQL Server authentication. If we look at files and file groups, in Azure SQL Database, we don't have that. So you just have one primary file group and one transaction log. That's it. In managed instance, you can have different files and file groups, but you cannot specify the file location. That is something that we decide because, yeah, it's a PaaS solution. But still, you can have different files and file groups. That is possible. The recovery model of your database is always full. It cannot be changed. The reason for that is that we need to guarantee 4.9, so 99.99% uptime. So we need to be able to restore your database or do a point-in-time restore of your database, which means we need to have full recovery model. Other different options like putting a database offline, putting a database in read-only or single user mode is not possible in Azure SQL Database. Other considerations. Usually when you have installed your SQL Server, you have to configure your TempDB depending on the number of vCores that you have in your server. Here again, in our PaaS solution, you don't have to specify anything for the TempDB. We do that for you. On the logical server that is used by your Azure SQL Database, you get 32 gigabytes size of TempDB per core that you use for every database, right? If you look at managed instance, it's 24 gigabyte size per vCore for the entire general purpose tier and limited in size on the business critical. Also, maximum server memory setting, also something that you normally configure on your SQL Server instance, your traditional SQL Server instance, is not possible to set. All right, so these are the differences between installing a SQL Server, just a bunch of settings, and then configuring. You need to specify which service tier you want to use for your database or your managed instance. Before I move on to the next topic, backup and recovery, are there any questions, Benny?
Well, there is one question in the chat so far, but I am also assuming that you'll cover it as well. Koen wants to know, what about elastic pools? How would you go about setting those up?
Elastic pools is exactly the same as, yeah, good point. I didn't mention it here. So you need to specify a pool and you need to specify the service tiers for a specific pool, right? And then you need to add these databases into that particular pool, and they're going to share the resources of that particular pool. I didn't want to touch Elastic database pools here, otherwise, the session would be too long. But if Koen has questions afterwards, I'm happy to answer those.
Right.
Elastic pools.
Great. Thank you.
Okay. Good. All right. Now, what about backup and restore? Like I mentioned, for me personally, I think it's the most important thing of a DBA. So be able to recover your database at all time. Right. Now, in Azure SQL DB, you don't have to worry about anything because we are taking backups for you, right? So every week we take a full backup of your database, and on a daily basis we take differential backups, and every 5 minutes we take transaction log backups of your database. So with that we can guarantee the SLA that we define for our PaaS solution. Now, on a daily and a weekly basis, we're actually going to copy your backup files from one region to another region. So our regions are paired, which basically means so it is geo-replicated, which means that if one of our regions goes down, you can still restore your database in another region. So it's the pair data center that will also have that backup file. So we're sure that we don't lose any of your backups here. We do exactly the same for managed instance databases. So there's no way you can interfere in our backup schema, except for managed instance. There you are allowed to take backups of your database. So backup database command works on a managed instance, but it is mandatory to use the copy only option so that, again, you don't interfere with our backup schema. The backup command in Azure SQL Database does not work at all. So that's not supported. Okay, for restoring, if you want to restore a database, it's pretty simple. It's a few clicks. I will demonstrate it immediately. So you just need to specify the date and the time when you want to do the point-in-time restore. You click OK, and we are going to restore the database for you. You cannot overwrite an existing database, so you will have to first restore it next to the old one with the new name. Once the restore is done, you just have to rename the old database and then rename the new database into the original name. And that's how you do the point-in-time restore. Just a few clicks, easy peasy. Retention period of the backups. So by default, we keep your backup files for 7 days. If you want more, you can configure that, and you can go up to 35 days of additional retention. And that, of course, will require normally an additional cost. Why? Because you get the size of the database, you get that storage for free for your backup files. But if you go over that, we will charge you for extra storage. So that is the downside of keeping your database longer than 7 days. Yeah. All right. So that's the point-in-time restore and the backups as well. Of course, if you delete a database by accident, you can still restore that database back again. So we keep track of that, and we keep your deleted databases for the amount or the number of days that you have set for the backup retention. So if you say, okay, I want to keep my backup files for 7 days, we will keep a deleted database for 7 days. And you can still retrieve that backup and restore it again as your database. I will demonstrate also that immediately. Right. Now, in some cases, it might happen that your application requires a backup file that it takes longer than 35 days. So we have another functionality called long-term data retention, where we can actually keep full backups of your database up to 10 years. So you just need to specify a storage account, and we can then actually keep your backups for more than 10 years. So you just need to define which backup you want to keep. And again, we do the rest for you. That's what we call the long-term data retention. Another option is that you generate a backpack of your database and move that to an external storage. That's also another possibility if you don't want to use the long-term retention period here. All right. So quick demo. How can you restore a database? So let me jump to my Azure portal. So this is my logical server. It's called PVH v12. As you can see, I have here already a bunch of databases, and I'm missing AdventureWorks here. So I had it before, but apparently somebody, removed it. So where can I restore this? If you go in the portal and you go to your logical endpoint, then here you have an option called deleted databases. And as you can see, okay, here AdventureWorks is still here, and the deletion time was the 18th of May. So apparently yesterday somebody deleted my database. Now, if you click on that database, just specify the target server. It automatically knows what was the latest point in time. You can specify your database name here. That's actually the only thing that you need to do. Let's call this AdventureWorks. Click OK, and there we go. So actually what I have done now is I have requested a restore, right? So now Microsoft, we are actually going to restore this deleted database back on the logical server. Yeah. If I look at another database, Wild World Importers, for example, let's say I made a mistake an hour ago. I dropped by accident, I dropped a table, and I need to restore that database up to the point of 1 hour ago. What I can do here is I can just hit that button, restore. It's a point in time restore. Let's call this Worldwide Importer Standard number 2. Here again, you need to specify the day and the time that I want to do the restore. Let's say, okay, I want to go back till this afternoon. You can also specify a different service tier if that should be necessary. Then you just hit OK, and that's it. So now you have actually requested, again, a restore of a database. We in the background are going to fetch the correct backup files that we need to do the restore of your database. So the life of the DBA comes pretty easy if it comes to backup and restore responsibility, because backups, you don't need to do anything. And if you need to do a restore, it's just a matter of a few simple clicks, and then you can actually restore the database yourself. All right. Let me jump back into the presentation. Are there any questions, Benny? Because
there is one question so far from Reitze Eskins. He wants to go back a bit to serverless Azure SQL DB and TempDB. Let's say that he's got serverless Azure SQL Database with a 1 core minimum and a 4 core maximum. What will happen to TempDB? Will it be 4 times? Will it use the maximum or the minimum for TempDB?
That's a good question. Because serverless is not a service tier, so it's part of the general purpose. So if you configure your database, you have to select, okay, I want to use general purpose, and I want to use the serverless option as well. So you will use the TempDB configuration that is available for the general purpose.
Okay, yeah, thanks.
Yeah. All right, good. Let's move on. Another task that I call the DBAs normally do is patching SQL Servers. So we recommend always install the latest CUs or install the latest service packs. And that's usually, a nightly intervention, or when during the weekend when nobody needs to use the database, because patching usually involves or a failover or a restart of SQL Server. So yeah. Now, how do we handle patching in Azure SQL Database and managed instance? Well, again, very easy. You as a DBA, you don't have to do anything at all. We do the patching for you. Azure SQL Database, we always run on the latest version of the engine. So we always run, and if you can compare it, we run on the latest version of SQL Server 2019 under the hood. Yeah. Now to update that SQL Server version, we also need to stop the SQL Server process, right? If that process is hosts on the primary replica, so as you know, if you create an Azure SQL database, we keep 3 copies of your database under the hood. If we need to update that primary replica, we need to first perform a failover. Now, performing a failover means impact on your workload because it can abort all the transactions that are currently open on your system. Yeah, which means this is an impact for your workload. Now, even if they are quick, these workloads, it still gives an interruption, and your application will need to reconnect. And it can, if you have, for example, a huge transaction that was at that moment was ongoing, and then we actually do the failover. Yeah, you need to restart with that complete transaction over again. So that's not a good approach, right? So when we patch, we try to minimize the downtime of the system. So what we do is during the upgrade, we ensure that we actually have hot standbys available that can take over immediately. Yeah, that's one thing. We apply updates to all the components. So not only Azure SQL Database, but if we know there needs to be other patches done, we apply all the updates to all the components in the same stack at the same time. So that could be the operating system, the service fabric under the hood, and SQL Server. So it's not that one evening we're going to update the operating system, and then the next evening we're going to upgrade SQL Server. No, that's not how it works. We also have automatic scheduling that avoids deploying during an Azure region's core business hours. So it's not that, for example, Western Europe, that we say, hey, let's start patching 10 o'clock in the morning when everybody starts using the systems. No, that's not how it works. So we do automatic scheduling, and we actually just wait and look at what are the business hours of that region and what are the lowest hours where we can do the patching. Also, just before the failover, we try to attempt to drain the active transactions, so to avoid aborting them. Like I mentioned, a long-running transaction, if it gets aborted, it will need to be restarted, and that's something we try to avoid here. We even utilize database workload patterns. So we look at the workload on your database to perform a failover at the best time for the workload. So if we notice that there is still a peak workload at 11 o'clock in the evening, we're not going to do the patching. So we also look at the workload patterns of your database. Now, the thing is, failover is still a failover, and we try to avoid that. So we came up with another solution, which is what we call hot patching. And that is currently what we're using in Azure SQL Database when we do our upgrade. What is hot patching? Hot patching is actually modifying in-memory code in a running process without restarting SQL Server. So in our case, it gives the capability to modify the C++ code that is used in the SQL Server engine without restarting the SQL Server exe process here. Yeah. So it means since we don't restart, we don't have to fail over, which means we don't interrupt your workload. So that's we don't even need to pause the SQL Server activity while we're patching. So we're just patching without the user actually knowing this. Yeah, and that's a huge improvement compared to what we had in the past, where we had to stop the SQL Server process and do the failover. So hot patching does not replace the traditional restarting upgrades. It just complements them. And to give you an example, more than 80% of all the SQL bug fixes and hot patches that we're doing are, and the patches that we're doing are done by this hot patching. We still have larger upgrades, and that's typically when we have new functionalities that are introduced, new major features. So that is something we still cannot do with hot patching. So these are still updates that require a restart or the failover from the primary to the secondary replica. Yeah. So what are the benefits of these hot patching? Of course, we reduce the workload disruption. We don't need to failover. We don't need to stop the SQL Server process. We can do much faster bug fixing, yeah, because we can just do it on the fly without having any impact to the customer workloads to deploy it again. And we can have features available much sooner because of these hot patching. If you want to know more about this, there is in my presentation. I will send it to you afterwards, or probably you will be able to download it somewhere. There is a link in my presentation where it goes to a blog post that explains this whole process. It's pretty technical, but very interesting to read how it actually works. So that's patching. Now, the thing is, and we get a few complaints by our customers that they say, yeah, but still we want to know when Microsoft is going to do patching on our system. We still want to know this. And for the moment, we don't have any functionality on this. And this is something new that I am allowed to tell now, is that we will have a new functionality, which is called maintenance windows and notifications. It's currently in private preview. So if you're interested in using this functionality, let me know. But how does it work? So you will get a set of predefined maintenance windows, what we call fixed maintenance windows, where the customer can choose from, right? And in that way, you can actually then pick your own maintenance window so that you know, okay, I have here a preferred slot in the weekend from Saturday 10 o'clock in the evening till Sunday morning 4 o'clock. So you will be able to specify that as your fixed maintenance window, which means that we will guarantee that we will do our patching during that maintenance window. Yeah, and you will even get notified 24 hours a day, 24 hours in advance. 24 hours, okay, it's not that much, but at least it's something. Like I mentioned, it's still in private preview. Probably that notification will be increased and go above 24 hours, of course. Okay. Now, the notifications, yeah, like I mentioned, it is you will get notified by that. This will be available for Managed Instance and Azure SQL Database, so both of them. And the product team actually asked me, if you're interested in this feature, here in the slide deck, help us polish some remaining rough edges on this feature. So they're just asking if you can take the survey. It only takes like 1 minute to fill in a bunch of questions so that they can get a better idea of what people actually want about the maintenance window functionality and the notifications. What they already noticed was that customers, if they choose for the PaaS solution, they just want to be notified when the upgrade will be done. And there are, of course, customers that also want to specify when the maintenance windows should occur. All right. Any questions on this, on the patching?
No questions so far, Pieter.
Right, perfect. Good. So if we compare that to the SQL Server or the traditional SQL Server, again, your life gets much easier because you don't have to do anything on the patching. Just maybe in the future, specify a maintenance window. That's it. Okay. Next topic, database maintenance. Somebody mentioned that in the chat when I asked what are the DBA tasks, and indeed, database maintenance, do index defragmentation, update statistics, and DBCC check DB. So how does this work in Azure SQL Database? Now, I've recently found an interesting, it was not a blog post, it was on Stack Overflow, a discussion on whether index maintenance is still necessary on Azure SQL Database. And Connor Cunningham, he had an interesting thought about it. And yeah, I could follow him in his statement here. And he said, is it still necessary? Well, it may not be worth your effort. And what he meant by that is the following. So Azure SQL Database is currently running on SSD disks. So the SSD fragmentation impact is relatively low if you compare it to the old disks that we have with the old spindles. So he said, yeah, look at the query store first and look if and evaluate if index rebuilds will help your performance, yes or no. So it's something from the past where people say, yes, you have to do index maintenance no matter what, it will improve your performance. Well, think twice before you look into index maintenance on Azure SQL Database. The thing also with Azure SQL DB is that there is no intra-database resource governance compared to SQL Server, which means that if you launch an index rebuild, it will consume all the resources of your database. So you might end up with some issues for your production load when you run an index rebuild. Yeah. And then it is not necessary to rebuild an index just to rebuild the stats. As you know, the update statistics policy has been changed a lot and improved a lot. So it's not necessary to do a rebuild of all your indexes if you just need to update the statistics. Yeah. So what I'm trying to say here is, just don't blindly configure index maintenance because it can have an impact on your production environment, especially in Azure SQL Database. So think twice, look at the query store and see whether index maintenance can actually improve the performance of your database. If you think, yeah, I need index maintenance, what are your schedule options then? And we have two. You can actually use Azure Automation, where you need to specify a runbook. And that runbook, you can schedule that runbook just like you can schedule a job in a SQL Server agent. But my preferred solution here for index maintenance would be the Elastic Jobs. I'm come back to that immediately when I'm talking about scheduling jobs. So we have a new functionality called Elastic Jobs for that. All right. Now, what about database integrity checks? We had a question for that before. If it's still relevant to run dbcc check DBs. Now, the command is still supported. So if you want as an end user, you can still run it. But in fact, it's not really necessary. So we are actually monitoring the integrity of your databases. So we, on an ongoing basis, the Azure SQL Database engineering team, we automatically test the restore of the automated database backups so that we are sure, and then we actually run our own dbcc checkdb tests on that. So any issues that we found during these integrity checks will result in an alert to the engineering team. So they will get an alert, and then we'll see that in the next slide, you as an end user will be notified that, hey, we found a corruption in your database. Yeah. We also use an additional functionality to detect what has been the most common cause of the physical corruptions, which is the IO system lost writes. This functionality tracks page writes and their associated LSN. So LSN stands for the log sequence number. Any subsequent read of that data page from a disk will be compared with the page's extended LSN. And if there's a mismatch between that, it means that the page is corrupt. And again, the engineering team will be alerted again. We also use the option automatic page repair. That is something that is already used since database mirroring. where you can actually take a page from a replica of your database and restore it. So that's the automatic page repair. We also use this same technology in Azure SQL Database. Yeah. And data integrity at rest and in transits. So we always do the checksum, of course, on your database as well. Now, what happens if your database is actually corrupt? What do we do? So incidents that do not have any impact to the end users, we're not going to tell you anything at all, and we're just going to fix the problem for you. So you won't even notice that there was any corruption on your database. Some of these incidents could benefit, for example, from the automatic page repair, or there is a corruption in an internal database metadata, or there is a corruption in the telemetry data that we have. So these are things we can fix without even notifying the customers. Yeah. Now, once we actually find the corruption in the database, you will be notified immediately by our support team, and they will work directly and closely with you to explain, first of all, the scope of the corruption. So what is actually exactly corrupted in your database? They immediately going to initiate a restore, so a point-in-time restore prior to the corruption, and make that available for you free of charge, so that the customers can then start looking what kind of data can we still have. Yeah, and the repair is achieved using various methods. So yeah, we can. If it's a rebuild, that's exactly the same like in an on-premises or in a traditional SQL Server. So if you just rebuild an index of a non-clustered index, then the corruption can be gone. We can even try to do repair with allowed data loss, of course, but then, of course, we need to have the confirmation of the customer that we can do that, and so on. So there are different approaches that we can use, or that we use, and where we work together with the customer, of course, to get your database back up and running without any corruption. Yeah, but still, feel free if you still want to run your own integrity check. The DBCC, checkDB command is still supported, and you can do that. Again, be aware that there could be some heavy load on your database when you start running that. All right. Let me pause again for a moment. Any questions on database maintenance and integrity check?
No questions so far, Pieter.
Perfect. Means that my explanation is good. No, just kidding.
No, it is. It is. Even I'm understanding it, and that's a dumb BI guy. So
yeah, that explains a lot. No. Anyway, let's move on. HADR setup. So the DBA is also usually, in my case, I was responsible to set up availability groups, to set up failover cluster instance. How does these things work in Azure SQL DB? What can you set up, and what is done by us again? Now, first have a look at the high availability, and that is something that is provided by us. So as I mentioned before, when you create a single database, we actually make 3 copies of your database, 1 primary and 2 secondaries, which actually means if your primary fails, the other one of the secondaries becomes the new primary, which means at that moment we will have a failover, and your application will need to reconnect. So be sure that your applications always use a reconnect mechanism, especially when you use Azure SQL Database. So this one becomes the new primary. And then what we will do is we will actually create a new secondary and start replicating again to the other 2 new secondaries. So we always keep 3 copies of your database. And with that, we can actually guarantee the high availability of your database. Do you need to do anything for that? No. This is something we do for you. From the moment you create a new database, we create 3 copies of your database. And that's the reason why it takes a little bit longer to create a database in Azure compared to a traditional SQL Server, because we need to, under the hood, we need to create 3 copies of your database. Yeah. High availability. Out of the box for you. You don't need to do anything. Now, if we look at disaster recovery, there are several options. The first one is, I already briefly explained it when we talked about backup and restore, is the geo restore. It's no extra cost, so at least it gives you some basic possibility in case of disaster. What we're doing is we're copying your full backups and your differential backups from one region to another. So we have region pairs in Azure, and we're actually replicating these backup files from one region to another on Azure Storage. Which means that in case one of our regions is unavailable, you can actually initiate a restore request of one of these databases. So the RPO will be 1 hour and the RTO will be 24 hours or more. But still, it gives you a basic option for disaster recovery out of the box with no extra cost, the geo restore. I can imagine that some applications, they have higher SLAs than that, and then we can actually configure what we call geo replication. And if you're familiar with the always on availability group concept, well, it's exactly the same that we're going to do here. So we're going to replicate your database from one region to another in what we call failover groups. So we will have one primary group and one secondary group of databases. So you can actually replicate from one data center to another. You can choose to have automatic or manual failover of the databases. So in case one of our regions goes down, you can say, let's wait 1 hour. And if the region is still down, okay, then do an automatic failover to the other region. So that's a possibility. You can also choose to say, no, I want to do a manual failover. And in my opinion, if you are in a DR situation, I would go for the manual option. I think the DBA needs to be in charge when the failover needs to be done. And in my opinion, it shouldn't be done automatically, but that's just my personal opinion here. The failover groups, excuse me, and the geo replication is available in all service tiers. So if you go for general purpose or business critical, doesn't matter, you have this functionality here. We also have the concept of a listener. It's not really a group listener like you know it in always on availability groups, but it's a listener on an endpoint. And it also will move if you do or if you perform a failover. So the DNS records, they are automatically updated after the failover is done. So I don't know how many of you people have already set up an always on availability group, but let's say it's not that difficult, but it's a lot of work. So you need to build a failover cluster instance. You need to then configure the replicas. Then you actually need to configure your availability group. And then you need to add the databases into the availability group. Now, let me quickly show you how easy it is in Azure to replicate your database from one data center or from one region to another region. So okay, so how can you set up failover groups? Go to the portal. Well, not to the portal. I go here. So this is my management studio. And as you can see, I'm connected to 2 logical servers. So I have my PVH V12, which is running in Western Europe. And I have another logical server, which is PVH Nordic. And as you can already guess, probably that one is running in North Europe. And what I'm going to do is I want to replicate my database Wild World Importer Standard. I want to replicate that from Western Europe to Northern Europe. Okay, so I go to the portal. And I go to my server here. And here on the server itself, so I'm connected now to PVH v12, you have the option failover groups. There are no groups created. I'm going to add a group. Let's call it dataMinds D from failover group. Okay, that's not allowed. It needs to be a dash. Okay. Then I need to select my secondary server. So in this case, it's going to be the Nordic server. Here I can actually specify what do you want. Do you want to have automatic or manual failover? So let's go for manual failover. If you choose automatic, then you also have to specify the grace period, which means how long do we have to wait until we can do the failover. So you can select from 1 hour up to 24 hours that we have to wait until the database comes up again. Excuse me. All right, but I go for manual. And the databases that I want to add into my group, so these are all the databases on my list. And I will go for this one. On my list, what did I say? On my server here. Yeah, so these are the databases on my PVH v12 server. And I go for White World Importer Standard. Okay. Select. Create. That's it. So now we are currently deploying this. Just give it a few seconds to come up. There we go. So this is our group. And the cool thing is now that you can have actually here, you see a map, and then you can see that it's replicating. If you see the dashed lines, it means that it's still replicating. Excuse me. So it will just take a few more minutes to replicate from Western Europe to Northern Europe. Here you can also see the primary is my server in West Europe. Secondary is the other one. And these are the listener endpoints. So you can actually compare those to the always on availability group listeners. So you can use these listener endpoints in your connection string, which means you will always point to the correct primary here. I'm sorry. Okay, where was I? Yeah. So it's replicating now. So if I go back to my management studio and I do a refresh here on my Nordic server, then you can already see I have my White World Importer Standard database is already available in the Nordic server. And I can expand this. And the good thing about this is also a readable. So you can again offload. Okay, I still don't have the tables because it's still replicating. It's there. So let's go back to my management studio, do refresh. It's weird. Good one. There are no tables in it. Okay. All right, my mistake. Anyway, normally when the tables are replicated, the database in the secondary server, let's say, is readable. So you can then again offload your readable queries if that should be necessary. So compared to setting up an availability group, this is just, again, a matter of clicks. Even Benny could do it. And yeah, you just set it up and you start replicating your database over different regions. Of course, this comes with an extra cost because you also will be charged for the database in the second region as well. Okay. Good. Any questions on this?
Yeah, there was one question, but I actually think that we've answered most of this already. Koen wanted to know if Geo Restore is automatically included.
Yes.
Yeah.
Yes, you don't have to configure anything. So from the moment you create a database, we automatically take a full backup of your database, and it's already automatically replicated to the paired region. So it's, again, fully automatic. You don't need to do anything at all. And at time of a restore, you will notice that the database in the paired data center will be available for you.
Okay,
All
thanks.
right.
That's all the questions for now.
Okay, perfect. I'll need to speed up a little bit. So let's talk about security. So usually in a traditional SQL Server, you need to configure your logins, server logins. You need to configure your Windows users, Windows groups. You need to give them permissions on a server level or on a database level. Now, if we compare that again to Azure SQL Database, well, since we don't have really a server, we had just like a logical endpoint. There are no server roles. Well, there are some special roles, but we don't have system administrator. We don't have data reader, data writer. These are things we don't have. Or sorry, server admin. These are all roles we don't have. The database roles, so data reader, data writer, DB owner, these are all the same compared to a traditional SQL Server. Why? Because yeah, the application users, they can do inside their database whatever they want, but outside the database, there's nothing. There is no real server, so we don't need to use any server logins. If we look at managed instance, yeah, there we still have, since we talk about an instance, we still have their server logins. And you can also have their same concept as server logins that are linked to database users. Yeah. Now, what else do you have to keep in mind when you want to configure the security is the firewalls, right? When you create a logical server or a managed instance, you need to specify firewall rules. Which client IP addresses are allowed to connect to my logical server or to my managed instance? So initially, when you create an Azure SQL Database server, everything is blocked. So nobody can connect unless you decide which client IP addresses can connect to the server. And you can configure firewall rules on a server level or on a database level. So which means that if you configure them on a firewall level and somebody tries to connect, first thing that we're going to do is we're going to check whether the client IP address is in the range of the server level firewall rules. If that's the case, then you will be allowed to connect and you will be able to connect to the database where you have the appropriate user for. If we cannot find your IP address in the server level firewall rules, we're going to check whether there are database level firewall rules configured for database 4, the database, for example, you want to connect. If that's the case, okay, then you will be allowed only to connect to DB4 in this case. If not, it means that your client IP address is not allowed and your connection will actually fail. Yeah, so that's one thing you have to keep in mind that is different compared to traditional SQL Server. Here is on your database server, you need to configure firewall rules before anyone can connect. I already mentioned that before, Azure Active Directory authentication, that is not on by default. So you also need to specify on your logical server an Azure Active Directory administrator account. And once you configure that, from that moment on, you can start using Azure Active Directory authentication. As mentioned before, Windows authentication does not exist. And what we recommend to our customer is to use contained database users. So it means that we keep, especially for Azure SQL databases, it means that you don't need to create any server logins. You just need to create a database user that contains the login information directly into the database. It's called contained database users. If Azure Active Directory authentication is not an option, then the only alternative that we still have is SQL Server authentication. But this is exactly the same compared to traditional SQL Server, where we also recommend to use Windows authentication because you can play with the Windows groups put the restrictions or put users into the Windows groups and leave the security in Azure Active Directory or in Active Directory and just configure the groups on your SQL Server. Yeah. We also now have private link for Azure SQL Database. if I go back to the firewall settings, this means that actually the public IP address of your client needs to be in the firewall. Now, the thing is that many customers, they don't allow public internet access to a SQL database. So to address this problem, we introduced a new concept called a private link for Azure SQL Database. So when customers connect to the public endpoint from an on-premise machine, their IP address needs to be added into the IP firewall, like I mentioned before, right? With private link, customers, they can enable cross-premises access to a private endpoint, for example, just by using ExpressRoute or a VPN tunneling. Yeah, it means that when you configure this private link, you can only connect from a particular subset and one particular IP address, which means that in that case, the customers can disable all the access via the public endpoints, and so it means they don't need to use the firewall settings anymore. So this is pretty new. Have a look at it in our documentation. Private link for Azure SQL DB. But it just allows you to connect privately to your SQL database, and you don't have to, or you don't need to have any access to the internet at all anymore if you want to use this. All right. Good. Then these are the main differences basically compared to a traditional SQL Server. So the firewall rules, Azure Active Directory, and the private link. Everything else, the concept of the database roles, setting the different permissions, this is exactly the same if you compare it with the traditional SQL Server. All right, next topic, job scheduling. So pretty easy in traditional SQL Server, you have the SQL Server agent, you configure the jobs, that's it. If you look at managed instance, we also have a job or a SQL Server agent there. So no big deal to schedule jobs on a managed instance. But what about Azure SQL Database? We don't have a server, we just have a logical endpoint, which means everything outside the database does not exist, which means a SQL Server agent does not exist. Now, a few years ago, we got, let's say not plenty, but we got complaints about, but how can we schedule the jobs? We need to use Azure Automation, and we don't know how to create runbooks, and it's too difficult for us. So, we came up with a solution, and it's what we called Elastic Database Jobs. It's still in public preview, but it should be GA pretty soon. And what it does, it does exactly the same like a SQL Server agent. So you can schedule jobs that can run against one database or multiple databases in a server. It can run against an Elastic database pool, just a bunch of databases, you name it. So it is even more flexible than the SQL Server agent. Now, I'm going to skip this one. So if we compare it, what do you need to do is, first of all, you need to configure an Elastic Job Agent. That is a new service that you can just configure on our platform. And when you create a service, you need to specify what we call a job database. And in that job database, we're going to store all the related data to the job definitions, the history, and so on. So basically, that job database that you configure, it behaves the same like the MSDB in a traditional SQL Server. Then, once you have this, you need to define a target group. So against what do I want to execute my job? And that could be a set of servers, could be a pool of databases, could be just one single database. You have different options here. So that's a difference compared to a SQL Server agent job, where you just can specify, run the job against one particular database. Here you can actually specify a target group. And then the last component is the job itself. So that is, you can compare it to the job steps of the SQL Server agent. So which commands do you want to execute against the target group? You also need to configure job credentials when you want to do this, because the service needs to be able to connect to the master database and needs to be able to connect to the target user database. I don't have enough time to go much into detail, but I'm really a fan of this feature, and it's not used very often by customers, mainly because they don't know the functionality. If you want to have more information on this, just let me know, and I'm happy to give you more details on this. All right, any questions, Benny, on this?
Nope, no questions so far, Peter.
Very good. Okay, I'm almost there. Database migrations, also another task, according to me, that needs to be done by the DBA. So move your database from one server to another. In a traditional SQL Server, fairly easy. Back up the database, restore it on the other server, copy the necessary server logins, change the connection string, and you're good to go. Now with Azure SQL Database and Managed Instance, restore of a database is not possible in Azure SQL DB. It is in Managed Instance. So if you want to migrate to Managed Instance, you can still take a backup of your on-premises database, copy it to an Azure storage account, and then from that Azure storage account, you can restore that database into a Managed Instance. So that's still a good way of migrating to a Managed Instance. But we have other functionalities. And what usually in a migration journey, so we have on-premises. So let's look at SQL Server, right, on-prem. First of all, what you need to do is you need to assess whether your database is compatible to move to a managed instance or move to an Azure SQL database, because not all functionalities that you're used to have in a traditional SQL Server are available in Azure SQL DB. So you can do an assessment. That is done by the DMA, the Data Migration Assistant, and the DEA, the Data Enterprise Assistant. I'll go back to that immediately. Another option that you can use is the Azure Database Migration Service. This allows you to, for example, do even online migrations. So I was talking about backup restore, but what about large databases that cannot be down for, let's say, 10 minutes? So we have to reduce the migration time. So we need to use some kind of online mechanism. And with that, with Azure Database Migration Service, or DMS, you can actually configure online migrations from on-premises to Azure SQL Database, for example, or to a managed instance. So that's the journey that you have during migrations. The Data Migration Assistant is a tool, again, where you can do the assessment. So it will discover issues that can affect when you upgrade to an Azure SQL Database. And it will also give you an overview of migration blockers, of behavior changes, and so on. So if you notice in this tool you have migration blockers, you will first need to fix them before you can actually then migrate your database to an Azure SQL DB. That's the Migration Assistant. The Database Experimentation Assistant, or the DEA, it's a tool that is not often used, but this tool allows you to, what it does, it captures extended events and traces from your on-premises workload, and you can actually then replay that workload against a database in Azure SQL DB. And this is a tool that can be used to verify whether the performance of the Azure SQL DB, whether this is going to be okay if you want to run your current production load. Yeah, so that's the Database Experimentation Assistant. And then we have, like I mentioned, the DMS service. So basically, it's a service that you need to configure. Under the hood, we're actually going to create a virtual machine for you, but you can never connect to that at all. And it allows you to migrate sources like SQL Server on-prem, for example, to Azure DB online or offline. It allows you to migrate from Oracle, for example, to SQL, or it allows you to migrate from MongoDB to Cosmos DB. So it's a service that can help you with migration from on-premises to let's call it a data flavor in Azure, the data migration service. Okay. All right. And then the last topic that I consider as a task of the DBA is reviewing the performance metrics. How performant is your SQL Server running? Are there any locks? Are there any deadlocks maybe? What is the CPU usage of my server and so on? So these are things that the DBA can monitor. And you can still do the same in Azure SQL Database or on a managed instance. We have different system tables called the sys resource stats in the master database. And we also have the other one, which is the sysdmdb resource stats that is stored in the user database. That gives you a performance data of your database as well. Now, in the portal itself, you also have different graphs like CPU percentage usage, memory usage, and you can even then configure alerts on that so that you will be notified, for example, when the CPU of your database goes above 30 or above 80%, for example, during the last 30 minutes. Yep. So these are resource monitoring in the portal or with the traditional DMVs, and these extra DMVs and system tables, you can monitor the performance of your database. We also have a functionality called Query Performance Insight. This is basically the information that is stored in the query store. So when you create a database in Azure SQL DB, Query Store is enabled by default. And that allows you to drill down into different queries that do not perform very well. You can even see which queries it are. And then using the Query Store in the Management Studio, you can even then verify the query plans and notice, hey, there is an index missing, or yeah, we need to change the query here, stuff like that. So this is the Query Performance Insight. It's basically the Query Store under the hood that we're using. But you can access that information, again, from the portal itself. I'm going to skip this one. We also have the Azure SQL Database Advisor. This one will give you advice like, hey, maybe you can benefit from creating an index or dropping an index. Stan mentioned before that don't create too much indexes. Well, we have a tool that will give you index recommendations for you. So these are all included in the Azure SQL databases as well. And then we have the SQL Analytics. So all the logs that we have, we can capture those and send them to Log Analytics. And in Log Analytics, we have a special dashboard, which is the SQL, our Azure SQL Analytics, that gives you a nice overview of your whole environment and where you can monitor the resource usage, the query performance, the SQL errors, the timeouts, the logs, the blocks, and so on. So all this information is gathered in the Azure SQL Analytics. So you can still monitor everything here as well in the Log Analytics. All right, that brings me to the end. What have we seen? Or yeah, as I mentioned in the beginning, it's all in a nutshell. It's a high overview, but I think it will give you a good idea which tasks have changed and which tasks we are taking care of. So what have we seen during these 90 minutes is in the difference in installing SQL Server. So you need to specify a logical server or just a managed instance. Just fill in a few settings and then hit OK, and we will create the instance for you. We've seen the database configurations. So you just need to specify the different service tiers, general purpose, business critical, or hyperscale. I've talked about backup and recovery. Backups is something we do for you. Recovery is just, again, a matter of clicks, and then we will restore the database for you. I've talked about patching, which is automatically done, again, for you. Database maintenance, you can still do index maintenance, but double check whether this is necessary or not. And database integrity checks is something, again, that is done by Microsoft. And when we find corruption in your database, you will definitely be notified about that. We've talked about HA and DR setup, the failover groups. I briefly talked about the firewall settings that you have to configure and the private link. The Elastic jobs, how can you schedule jobs on Azure SQL Database, and then pretty quickly the database migration options that you have and the review of the performance metrics. All right, I'm done talking. Benny, I don't know if there are any further questions.
No, there's no new questions that have popped up in chat, and about 2-3 minutes ago I've encouraged them to start asking all those final questions. So right. I'm actually assuming that there's no questions.
Perfect. Okay, it's almost 9 o'clock. It's still very nice weather outside. I propose we just wrap up, get a beer, and go outside and have try to relax for a few more hours.
That is an excellent suggestion.
All right. Very good. Again, thanks a lot for joining. I hope you've learned something. In case you need anything, let me know. And I will definitely answer your questions. All right. Talk to you later. Bye-bye.
Okay. Thank you, Pieter. Thank you for presenting. Thank you, Stan, as well. And thank you for all the people watching the stream today.